Good morning, everyone. Like Faris said, I'm going to be talking about continuous deployment today, and continuous deployment in itself is not a goal, I think, but I'm going to be talking about a little case study, a real-life thing that I was part of in a company in the Netherlands, where I come from. I'll first introduce myself quickly. I'm a developer, a trainer, a consultant, and a speaker. If you want to reach out to me at any point during the talk, I won't address you or I won't answer, but I'll put the slides on there as well. That's my Twitter handle. And like Faris said, I'm part of a company, a Dutch consulting company called 4Scouts. Right, let's get going. This particular project took place in Amsterdam at the River I, which is a beautiful part of the city, for those of you that have seen it, and if not, you should. And this project took place in 2014-2015 at a company that has a large number of newspapers and online news sites, both in the Netherlands and in Belgium. But they also have job sites where people like you and me can look for new, better, interesting jobs, but also where recruiters or companies at large can post their jobs, can post their vacancies. Now, when I reached this project as an external consultant, what I found was a large and aging monolithic application, which had been in development over the course of 10 to 15 years. It was successful in that it generated money, significant income even, but it was dreadfully slow. Page load times over 5 seconds were not unheard of, and it was very complex. And fourth, there was a lot of technical debt as a result of a number of mergers, acquisitions, and cutting corners, essentially, over the 10 to 15-year period. Now, the team that I found there was 16 people, and they were doing manual releases roughly every month, but there was no fixed schedule, and typically during the weekend. Now, the problem with a job site is that it has two groups of customers. On the one hand, you have recruiters and companies that place their jobs on the site, and they typically do that on weekdays from 9 to 5. People that are looking for a job, regular people, typically do that after hours, so at night or during the weekend. So releases that would take the site down over the weekend impacted the people that were actually looking for a better career, for an improved life. They did that every 4 to 5 weeks, depending on the amount of work they wanted to release. And they had a lot of fragile tests. The tests that they were having, that they did have, randomly fell over. From one build to the next, these tests would fail, and then the next build, they would work again, and other tests would magically fail. So not very trustworthy. After releases, but also during the normal course of development work, a lot of the developers were dealing with issues. Firefighting right after release, so the weekend we go down, we do the release, and then the Monday, Tuesday is like, oh damn, we need to fix this and that. And as a result of all this, the team had low velocity, and now velocity in itself is not something I want to track, but it was an indicator that there was something going on. Another indicator was frustration. Low motivation within the team. Now, this is basically the setup, and management, the leadership, some people in the company said this needs to improve because job site is a very competitive market. Take LinkedIn, Indeed, and other companies that are fighting for their foothold there. So management set a few goals to deal with this whole scenario, this whole issue. And one of them is significantly reduce the number of issues that this company was dealing with, or that the development team was dealing with, so that they get more time for actual work. Reduce the lead time, where I mean the number of, or the time it takes for an idea to be usable in production, to be usable by the audience. And in this particular company, at that point in time, we could measure that in terms of 2 to 3, sometimes even longer, months. So an idea is formulated, and then 3, 4 months later, it is actually usable in production, which in a competitive market, as a job site market, is not acceptable anymore. Third, increase the productivity of the team if they don't have to spend that much time on issues and firefighting, then they can spend more time on actually delivering value. And fourth, increasing motivation and thereby retention, which is something that you don't hear a lot, I think, but especially for developers and testers and people in IT, there's a lot of choice, at least in the Netherlands there is. There's a lot of choice where you want to work. So if a company where you work doesn't use the latest methods, doesn't listen to what you think should be done, et cetera, then you leave and go to another company. So increasing motivation means that, and increasing the things you're doing and modernizing the way of working improves with retention and hiring secondary as well. Now with all these goals set, there's a number of questions that you can ask to how to deal with this. And two of the questions that were asked were, should we refactor the existing system or should we rebuild it? Well, refactoring was tried initially and very enthusiastically, and for the coders amongst us, after 3 to 4 months, we had a 2.5% code coverage, which is, from a relative perspective, it's an insane jump from 0 to 2.5, but in absolute terms, it's not something that is feasible. So that was off the table. Rebuilding was considered, and rebuilding is where we say, okay, we have system A, and then we build system B, and when system B has reached feature parity level, so it's doing the exact same thing as system A, then we flip that big switch, and that never goes wrong, right? Problem is also that a lot of the why behind features and functionality in the old system has disappeared. People have moved on to other jobs. Things were not documented. All sorts of, there were little shortcuts and corner cases for individual clients that may no longer be clients. So if you write a new system which exactly mirrors the old system, you build all these bugs which really have turned into features over all the time, and you rebuild them. And essentially you get a system which is pretty much the same, of the same level or a lack of level as the old one. So that was out of the question. So if the answer to these questions is no, then what is the answer? Well, I'll tell you. One of the things this company offered was APIs, where recruiters or companies that place jobs can automatically, from their own ERP systems or hiring recruitment systems, whatever, post them to our API, and then they come online on the site. Now, those APIs were always a second-rate citizen, second-class citizen, because they were not used internally. So that's something we tried to turn around. Use the APIs we expose to the outside world internally as well. And we moved towards a service-oriented architecture, where we looked at services per domain object. So we didn't think about microservices or macro services, just services. Small enough to work with, large enough to be useful, and oriented around domain terms such as the job or the job seeker. And because this was a website, we could get away with migrating individual pages, and I'll show you how we did that. On the left, we have a monolithic application which talks to a database and to somebody on the internet. Pretty straightforward so far. And then we add a proxy in between the internet and the monolith, and initially the proxy doesn't do anything. It just passes the traffic verbatim. And then we add a small service, which may or may not use its own database. And then we add a little piece of functionality inside that service. And then in the proxy, we add a rule. For page X, go to that service. Let that be served, let that be rendered or done, hosted by that new service. And then we add more services, and they all have little bits of functionality in them. And at some point, that functionality is good enough for the original monolith is not actually doing anything anymore, any useful work anymore, at which point it can be switched off and thrown away. This is what we call the strangler pattern, which lends its name from an actual plant in the wild, which grows on another plant and basically grows around it and grows around it until the original plant can no longer sustain life and dies, which is a little bit morbid, but that's what we want to achieve with our old system. Now, we also set a few architecture principles, if you will. This particular company had 3 different job sites. And they were all linked to the same code base initially, but we wanted to innovate on them individually. So we said front ends are going to be their own service, are going to be their own repository, are going to be their own innovation or own value stream. And we consider front end to be no different than a backend service. It exposes an API. The only thing is it will be consumed by a browser rather than another service. All the services are behind load balancers so that we can ramp up and ramp down at will, depending on traffic. And we can replace them without downtime, without anybody noticing that. The third, we need to access legacy databases from time to time, if only to clean up the old data model. And fourth, this was in the early days, the infancy of Docker, but we said containers for all the services. So we build our container image in a single place, and then we distributed that over our different environments. Right, this is architecture. Now let's talk a little bit about how we improved. And we improved using 1-week sprints, by the way. We could have done that shorter, maybe, but at least we had a 1-week sprint, which worked well for us. In that 1-week sprint, we basically did everything in a continuous fashion. And continuous everything, to me, is one of the key terms that's come out in the past few years, which is we are all used to thinking about things in terms of projects, which have a start date and an end date. And then after the end of the project, or we document things and we throw it somewhere, and then next project. When you think about products or experiments even, then things happen in a continuous fashion. There is a start date, and the end date is when it's no longer viable, but that's not fixed, that's not known right now. So we do everything in a continuous fashion. What we do in a continuous fashion is continuous integration, which is an older term coined by Martin Fowler years ago. And continuous integration is where a developer checks in some code on the left, and then a process starts running, and the code is built, tested, and then if the tests are green, if they pass, and the build's successful, then we have a uniquely identifying artifact, just one thing. It can be a jar or war or a zip or something, as long as it's one thing. But that's where it stops. Now, continuous delivery, which is one of those buzzword terms you've been hearing about in the past few years, takes that artifact and automatically deploys it to an acceptance environment. And on that acceptance environment, we have QA people, we have product owners, and everybody who's involved, testing, using the product, and verifying the build. And then at some point, somebody's going to say, the build is good enough, this can now go to production. The deployment to production should be automatic. It should be the exact same scripts as the deployment to acceptance. However, the trigger is still a human, somebody actually saying, this is good to go. Hence, the red arrow. And you've heard me talking about the term continuous deployment. Well, continuous deployment takes the human out of that whole pipeline. In the acceptance, we deploy automatically like before, and then we do some automated checks to verify that the deployment works, that it's okay. And if those signals are green, then we automatically and immediately deploy towards production. In my book, this whole thing should take no more than 30 minutes tops, from the very check-in of the code to the last deployment to production. Why? Because if you have a slow pipeline, a pipeline which takes 2 or 3 hours, people will tend to ignore it and not trust it, and then ignore it. So 20 to 30 minutes, I strive to be even faster than that, but 20 to 30 minutes, that's my personal benchmark for pipelines like that. Now, why the hell would you want to do this? Because every commit goes to production. That's what we're now saying, right? Every commit that has the tests pass, that has the checks pass, immediately goes to production. Which means that if I change the color of a button now and the test pass, it's in production 20 minutes later if we have a fast enough pipeline, or 10 minutes even if we have a faster pipeline. And why would we want to do this? Well, I'm a little bit of a masochist, and I say if it hurts, do it more often. And the funny thing is with deployments is that people tend to reduce their release frequency because they want to avoid risk, which is somewhat of a paradox. Because we want to avoid risk, we do 1 or 2 releases per year. And I can guarantee you, companies that say we do 2 releases per year actually do 4 or 5. because they have a heartbeat of once every 6 months, and then they have the oh shit moment where they need to fix the things that went wrong in the regular deployment. And people get scared about releases when you do them so infrequently. Every 6 months, people will work up to that moment, and it will be, we're going to go down for X number of hours. It'll be risky. There will be plans. There will be entire test scripts written, all those things. And if you do it 100 times per day, then it's, at some point, people will stop caring about it. We'll stop thinking about it even. And so we go towards small steps. Because if you deploy 100 times per day, the thing you can deploy is this big rather than this huge amount of commits, right? So small steps lead to early feedback. If my pipeline deploys my little commit to the production in 20 minutes, after 20 minutes I can verify whether my commit has had any change, right? Going back to hypothesis-driven development or metrics-driven development, I can see that metric move within 20 minutes after my commit. My time to recover is as long as it takes for a new commit to be deployed. So if my last commit broke everything, then I revert the last commit, I deploy that. And if that takes 10 minutes, then my fix is taking only 10 minutes. And that is a marked improvement. And this all leads to experimentation, where if we wait for 3 months for our regular release window, and then we do all these experiments, and they run for the next 3 months, all those experiments influence each other. And all the changes we did influence each other, and they muddy. They are variables that influence each other. We can no longer find their individual working. But rather, if we do a small experiment now, and we leave that in production for a few days, then take it out, then we have this very small data set, very concrete data set that we can work with. It means, to me, to successfully do continuous deployment and continuous delivery, by the way, at any reasonable speed, at any reasonable pace, is that we only should commit to master, which means that we shouldn't use branches. For the people that are very attached to that, no branches really. And I'm not saying that just to be cute. Thank you for the applause, though. But because this is generally, I don't usually get applause. I either get people who are downright hostile or laughing at me like, sure, getting rid of branches, that doesn't work ever. I mean, we've Git now, right? But this is one of the things that can happen. And it's funny to me that who here has ever used Subversion? The dinosaur speaking. Okay, that's quite a number of you. Who here ever dared using branches in the Subversion days? Okay, you're brave. You're brave. Was that before or after the merge info changes? Yeah, see? There you go. Before the merge info changes, and this is getting very technical, but almost nobody dared using Subversion for branching because it would simply break. At any reasonable amount of commits after the merge would simply break. Now with Git and Mercurial, branching is so cheap that we kind of forgot all about how that works, and we're going towards the branching model all over again. And this is just one of the side effects. Very muddy history, which doesn't show you anything anymore. But the most important thing is that branches delay integration. And continuous integration says that you should merge with mainline at least once a day. And so that means if you have a branch which lives longer than a day, you're already violating that principle and you're no longer integrating with the rest of your buddies. And integrating with mainline doesn't mean merging master into your branch. It's the other way around. Conflicts are another thing. Merge conflicts on the technical level are one thing and can be solved in a myriad of ways. You use mine, for example. That's one of the ways we could solve that. Or use theirs, and yes, I've been in both. But the feature conflict or the functional conflict is much more interesting. So we have this work on a feature branch, and let's say our definition of done says that the code on the feature branch should be tested before it is merged. So then the feature is tested in isolation on that branch, but it is never tested along with the other feature branches that are living. So we test it on the branch, and then at some point we merge, and then it goes to production. But the combination of all those things, regressions that we may have introduced in other parts of the system are not actually tested. Or we introduce more manual gauge, which only slows down the process even further. So conflicts are one of the merge conflict is one, but the functional conflict to me is the much more problematic or interesting. Now, people use feature branches for functional separation, so that you can only merge this branch when the feature is ready or when we can go to the market with this feature. Right? We can only, this particular thing, this campaign can only go live at November 1st, so we merge the branch. On November 1st, we let it build and we deploy. Now, that means that we have to hold off on deploying that until November 1st. And we have to hold off on deploying everything potentially until November 1st, because that's that single thing. Now, feature toggles are a good way around that. And the feature toggle basically allows us to decouple the deployment from the release. The deployment, to me, is a technical exercise. Deployment is a team thing. So a team should be able to deploy at any given moment of the day. A release, that is a business decision, usually. And what you get is something like this. On one of those job sites, we had a search page on the left, an old version, and a new version on the right. Now, the new version on the right took about a month and a half to build. If we had stopped deployments for that month and a half, then we would not have been able to deploy all the other things we were working on, right? And that would have been a shame. So what we did is, this was about 2,000 to 3,000 individual deployments, this whole thing, but it was behind a feature toggle. And the feature toggle is essentially a glorified if statement that allows you to deploy to production, but maybe that particular piece of code is dormant, it's sleeping. And it will only wake up when the feature toggle is active. And it can be active depending on, well, maybe you are inside the company network, and we can show the feature to you. And then we can set the feature toggle to 10% of live traffic, for example, so that 10% of the people that view the site see the one on the right, and the other 90 see the one on the left. And then we can take a hard, good look at the metrics and see whether this is better than the other. Well, in our particular case, in this project, we were replacing an older system. So if it's not worse than the old thing, it's better. Right? That was another of our little things there. But we could see the metrics, and then if the metrics are good, then we can ramp up the 10% to 50, and then to 100. And then we get rid of the feature toggle, because feature toggle debt is a thing. If you have hundreds of feature toggles in your code base, then you have this combinatorial explosion of potential code paths through your database, which all need to be tested, by the way. So our job as a team is, towards the product owner maybe, challenge them to either put it in 100% live, show it to everybody, and then get rid of the feature toggle, or if it looks like we're not going to go there, then ramp down to 0% and remove the functionality and the toggle entirely. Just be a little bit proactive about that. Now, branches are a popular thing in code reviews. Who here regularly uses pull requests to do reviews? Cool. I don't necessarily dislike the pull request. I use it for open source projects a lot. But when we talk about product teams or closely aligned teams, I tend to think of something that Peter also very briefly discussed, which is pair programming. And maybe not like that. Maybe that's not the most effective way to do pair programming. Why not? Well, hey, if it works for you. But pair programming, to me, leads to continuous inline code review, which is far better than the code review which a pull request enforces. A pull request, by nature, is asynchronous. And that means that I am working on this thing here, and then I submit a pull request, and that pull request goes to somebody who is working on something else. And I pull that person out of their context, and they need to work on the pull request. Now, research has also shown that the longer the pull request is in terms of line and complexity of the code, the less likely you're going to get a good review. If you're, I think it was 50 lines or something like that, that if you go beyond 50 lines, maybe it was 100, don't pin me on the exact number, but then people will scan it and will be just like, cool, merge. Which does not help in terms of quality. So rather than having all that context switching going on and people being pulled out of their work to look at your work, put those people together. And you get instantaneous knowledge transfer. Put a junior developer with a senior developer. Put a more ops person together with a more dev person. Put somebody with Elasticsearch experience with somebody who doesn't have that experience. You get all that knowledge transfer, and it helps with not creating silos, right? Now, DevOps, we didn't even know it was called DevOps then, but we did what we now call DevOps. And the funny thing is about DevOps, it's that it's become an umbrella term, like Agile and like other terms that we use. People have run away with it because they start adding things to it. And yes, I've seen it. And okay, we throw all those people into a single team, but to me it's a DevOps team or a team that works alongside or with DevOps principles. As Werner Vogel from Amazon said it 10 years or so ago, you build it, you run it. And there's just one more thing to it. Building is easy, running is hard, and improving, that's almost impossible, it seems. But to me, improving, running, building, improving, all those things should be within a single team. So a team should be responsible, essentially, for their product. Should be held responsible, but should also be in a position to be responsible, right? Now, let's tie all these things together into a build pipeline, which connects all the dots that we talked about. And the dots are cool, thank you. So the dots are repeatable things, and the dots should be automated as much as possible. The whole DevOps philosophy and continuous delivery philosophy too, by the way, is automate yourself out of a job. And the funny thing is, no matter how hard I try, I can't seem to automate myself out of a job because we come up with new things. But if you automate as much as you can, then you have more time available for the other things, right? And repeatable things, people tend to do very badly on them. You give 10 persons 10 tasks, and the next day, the same 10 persons, the same 10 tasks, you will already see variations in how they are executed, because we are not robots, right? We had a little bit too much to drink. We had a fight at home. We had a bad night's sleep or jet lag or something, and you will see variations. Scripts won't do that. Continuous everything also means continuous testing, and actually automated continuous testing, which helps with building confidence. Confidence that the change I make now is not going to seriously break everything in 10 minutes. And of course, nothing is ever watertight, but we can build up enough confidence so that we can deploy. And depending on the business you are in, there's a risk you are okay to take. And depending on if you're a bank, that risk may be smaller than if you're a job site. And a bank may invest more in managing that risk than a job site because going down, for example, would cost less than the investment against guarding against that. So you want to build in enough confidence that you need, but not more than you should. When it comes to testing, I'd like to think in terms of defending in depth, where we start at the unit test level, and depending on the language you love and use, it can be JUnit, NUnit, PHP unit, whatever, but the principles are the same. We have small units, small systems, small classes that are tested, and the world around them is mocked, so that our tests run fast and are cheap. And then we can build up towards the integration test level, where we actually talk against concrete databases maybe. We have fixtures, data fixtures with data that we know and that we can verify against. And then we can build up to scenarios, which are plain English versions of written functionality. Indeed, not in the terms of, as a user, I want a longer antenna, but in terms of functionality. What do I want to achieve? What edge cases are there? What examples can I think of? This is what they call a Gherkin script, by the way. And things like these are generally written up by the three amigos, which is, as one of my colleagues used to say, is where 3 is between 3 and 7, is a group of at least a business representative, usually a PO or a business analyst, a development representative, and a testing expert. And they together come up with the best potential version of a story that they can think of before the story is actually implemented, right before the story is implemented, just in time. And then there's UI testing, like Selenium or Cypress. Now, the manual tester amongst us, the QA person will ask, what is my role going to be? Because there's no manual testing anymore in this particular system. Well, actually, they will be more important than ever, because their whole work will be in front. And they will also do a little bit of exploratory testing, which is looking at a system and clicking through the most useful or most used, most critical parts of your code and see whether they still work. And then adjusting any tests that we have. This is the testing pyramid, where at the bottom of the pyramid we have the most numerous, the fastest, and the cheapest tests. So unit tests are typically what we have a lot of. And they are very fast, very cheap. And as we go up in the pyramid, tests become slower and more expensive. So integration tests, acceptance tests, UI tests, and then smoke tests. Now, smoke tests verify the health of a system. So by their very nature, need a deployed system to run, which makes them very slow. Monitoring on the right is an oft overlooked but very important part of testing, because not everything shows up in your test. Some things only break under load, under stress, at 5 a.m. at night. And your monitoring and alerting should tell you that that is happening, should show you that the number of exceptions is increasing or is going beyond our usable or acceptable threshold. And then maybe that would lead into a different test, a change in an existing test, or adding an additional test. But good enough is good enough, because the pipeline speed is essential. If we just start stacking and stacking and stacking on additional tests, then pretty soon we'll have a pipeline which takes 2 or 3 hours again, and people will ignore it. So we need to strive to only test what we really need to test. Now, in the deployment, in this particular project, we did something that is called a rolling update. And the rolling update essentially starts with our load balancer and the internet. And we have, in this case, 3 replicas of our service behind that load balancer, all version 1.0. And then we start adding version 1.1 of our service. Initially, it doesn't do anything, but then when it starts, we replace the 1.0 with that 1.1 version. And we repeat that, and we repeat that until we have replaced all the 1.0 instances with a 1.1 version. So from one to the next, we replace all the replicas. Now, if something were to go wrong, it typically would go wrong here. The service fails to boot, the new service, for example, the new version. And then we still have all those 3 existing replicas serving traffic, and there's really nothing going wrong. We just have to clean up that new version and try again with a new version. But hopefully everything will work well. And we are there. Now, this is only one way to deploy. There are a number of other ways. There is the canary release. There is the blue-green deployment. There's other things that you can look at. But for the sake of time, I'll just discuss this one. Now, everything, there's this whole XXX as code movement these days. And one of the things we did is the pipeline as code, where we actually write a pipeline, in this case in Jenkins, as a little bit of code. And in this case, we divide the build or the pipeline in different stages, similar to what I showed you earlier. We run the tests at the top of the screen, then we build our Docker image, and then we deploy first to staging and then to production. Now, these stages are sequential, which means that if one of the stages fails, all the subsequent stages are not executed, and the build is red, the build has failed. And we can show that in a little diagram, in a little graph, where you see the average run times for the individual stages. And if one of the stages then were to fail, it would color red, and all the other stages, subsequent stages, would color red as well. And if that were to fail, we want to know about it. The siren of shame, as we like to call it, which is not actually about shaming people, but is about triggering the team that the build broke. And triggering them to respect the build. Because if you do continuous deployment and you do trunk-based development or master-based development, you need to know that your pipeline broke. Because we're not doing manual deployments to production anymore. We only do it automated. So if the automation breaks, then that becomes an immediate priority 0 or 1 thing to fix. So that feedback is very key. Interesting anecdote, we were very close to a river which saw a lot of cruise ships pass along. There's a large cruise ship terminal in Amsterdam. And they use a foghorn to notice or to let everybody know that they're coming. And at some point we thought, oh, that's a cool sound actually. We didn't realize that if the siren went off and we used the foghorn, everybody ran towards the window and we're looking like, where's the cruise ship? Where's the cruise ship? And there wasn't any. And so after some point we changed that. Some people came home from holiday, they heard an actual cruise ship foghorn and they thought the build was breaking. So that was maybe not the best sound to use, at least not in that context. But it's very important that you know that the build has failed. Right, closing off with some results. The team acceptance was initially a bit of a problem. There were some team members who had been with that company for 8+ years, who had been doing the same, had been using the same way of working for those 8+ years. And they were like, okay, this is the next batch of external consultants that are telling us to do things differently. We did not try to enforce anything on anybody, because at the end of the day, that doesn't really work, especially not with people that are critical and professional. We instead tried to work as much with them to show that this is actually a better way, and that this helps to bridge the gap between development and business, which is a thing in a lot of companies. The feature toggle cap, I talked about feature toggle dat. Before we implement that, the cap, which is not a hard cap, but more of like a soft measure, we had a bit of a thing where we had too many feature toggles in the system, but we worked with that. Business alignment and the agility of the business is a real thing. At some point, we started moving so fast that we had lead time measured in 1 week, sometimes even smaller. And if the business is still expecting you to deliver things in 3 months, then interesting things can happen. For example, marketing materials that were usually ordered like 2 months after the thing was thought of, now are grossly late. So they needed to realign that a little bit as well. And we had an incident where they said, can you pull this out of production because we are not ready yet, which is a good problem to have. Then you're actually, continuous delivery is all about matching the pace of business. And so if you're faster than the business, you can slow down a little maybe. So that was a good problem to have. Unfortunately, the legacy monolith is still in production. I think it's serving about 20% of the traffic by now. And the idea is, as I understood, to have it out of production by January, which took about 2.5, 3 years. So that's a little bit longer than I think we would have liked. Now, what went well, significantly reduced the number of issues and the time spent dealing with them. The build time per service was under 10 minutes, so from the development check-in to the deployment to production. And we did over 50+ deployments, or over 50 deployments per day. All the metrics and audience statistics jumped up, sometimes very significantly. And the confidence, velocity, and most importantly, the fun of the team increased massively. At Forescouts, we have a little sub-label called Make.io, where we help other companies deal with continuous delivery, DevOps and Agile. If you're interested in that, please come find me after the conference. I'll be here all day, and we can talk about that. Thank you to all the sponsors for Bosnia, Agile. Thank you for having me. It's my first time in Sarajevo, and I absolutely love it. I'm Michiel Rook. You can reach me on Twitter, email, or on my personal blog right there. And thank you so much for your attention.